Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to look at this circuit and we're going to check the saturation of M2. In the previous quiz I calculated the drain current, which is I, is about 1 milliamp, and we already know why M1 is in saturation, but we didn't check our assumption about M2, and I'm gonna check this in this video. But before we get started, if you're new here, please give me a thumbs up, hit that subscribe button and also the notification bell, so whenever I upload a new video you'll be aware of it. Let's jump into it. So this is the circuit and these are all the assumptions. These are all some numbers for this problem, which was mu on silicon oxide, I, which is 1 milliamp, V threshold, and neglect the channel length modulation because lambda is equal to 0, and with the dimensions of transistors M1 and M2 we already calculated the I, which is 1 milliamp. So we know that M1 is in saturation. Why M1 is in saturation? Because the gate drain of M1 is equals to 0, which is less than with threshold voltage, so M1 is in saturation. For saturation, gate drain must be less than threshold voltage. But how about M2? For M2 we actually had to calculate the gate drain of M2. This is gate drain for M1, so with subscript 1, and for M2 I'm going to calculate the gate drain of 2. So gate drain, this is the gate and this is drain for this transistor. For gate voltage, here we have VDD 4 volt. So the gate is going to be, let me just rewrite it in here, the gate equals to VDD minus the voltage drop for 100 mega ohm. 100 mega ohm times the gate current of M2, which is 0, times 0. So this one is 0, so the answer is VDD, which was 4 volt. This is the gate voltage. How about the drain voltage of this transistor? This is the drain voltage of M2, VD2, and this is VG2. So V drain 2 equals to VDD, from here I'm using KVL, minus the voltage drop for 400 ohms. For 400 ohms, because I use milliamp for current, I'm going to use kilo ohm for resistance. So 0.4 kilo ohm times the current through it, which is I, is equal to 1 milliamp. So the result would be 4 minus 1 times 4, 0.4, this is 0.4, and the unit is going to be kilo, and milli are cross out. We have left with volt in the end. So the result would be 3.6 volt. So for this problem we can calculate gate drain 2. This is gate 4 minus drain, which is 0.6. So the answer would be 0.4 volt, which is less than threshold voltage, because threshold is 0.5. So the saturation in region for M2 is confirmed with this result. But before that, we have two conditions for saturation. First assumption is that the gate source voltage of these NMOS transistors. So we have to calculate gate source 1 for M1. This is square root of 2I divided by mu n silicon oxide W over L 1 plus V threshold. So this is 2 times 1 divided by 0.5 times WN1, which is 1, plus 0.5. So what is the result? This is actually square root of 4, which is 2, plus 0.5, 2.5. 2.5 is absolutely greater than threshold voltage, and You can get the same result for gate source 2. I mean the same result. I mean the gate source voltage of M2 is greater than the threshold voltage. For gate source of M2, let me just calculate this here. The gate source of M2 equals to square root of 2i divided by mu n C oxide W over L subscript 2 plus V threshold. Here we have 2 times 1 milliamp divided by 0.5 times 4 plus 0.5. So 4 times 0.5, which is 2, and 2 are crossed out. So 1.5 is answer for gate source 2, which is greater than threshold voltage. Just as a reminder, first of all, for saturation region, V gate source had to be greater than the threshold voltage. Then after that, if the gate drain voltage is less than threshold voltage, we are in saturation region for transistor, for NMOS transistor. But if the gate drain voltage greater than the threshold voltage, the transistor works in a triode region. And for this formula, I actually proved it in the previous video when I want to calculate the drain current of these NMOS transistors in the quiz. And it is better to know these relationships, not just a straightforward drain current versus gate source, which was a quadratic equation. You had to know this relationship as well. It's going to help you a lot in different problems, and it's going to make your solutions so easier to follow and understand the weight, and always try different relationships to make the solution so much easier and understandable. I hope you like this video. If that's the case, please give me a thumbs up and share this video with your friend. Thanks for watching. I will see you in the next video.